Hey everyone, we're going to go over Newton's second law. We're going to be able to understand and describe Newton's second law of motion. So Newton's second law of motion explains the relationship among force, mass, and acceleration. The relationship can be shortened to a mathematical formula commonly known as F equals ma, or force equals mass times acceleration. Force is measured in newtons, mass is measured in kilograms. A is acceleration, change in velocity measured in meters per second squared. To get a wagon to accelerate, you have to pull, which is a force. And if the mass of the wagon increases, a greater pull is necessary to accelerate it. Another way to think of Newton's second law of motion is to understand that acceleration is caused by a force and is proportional to force on the object. Greater force causes greater acceleration. Acceleration is inversely proportional to the mass of the object. The greater the mass of an object, the more it will resist any change in motion. So I have to apply more force to an object to get it to accelerate at a higher rate. Okay. Key ideas about Newton's second law. Acceleration of an object is determined by the sum of the forces acting on it and the mass of the object. If the total force of the object is not zero, it will accelerate in the direction of the net force. If the net force is zero, the object will not accelerate, but will continue its current state of motion. The greater the mass of the object is, the greater the force needed to achieve the same change in motion. For any given object, a larger force causes a larger change in motion. When mass of an object increases, acceleration decreases. When the force of the object increases, acceleration increases. So reference frames for motion. In order for motion to be described precisely, we need to use a point of reference, which is just the position that is not moving relative to the object. The motion of an object can often be described differently depending on the reference frame. For example, a person walking toward the front of the subway car may be walking 1 meter per second relative to the passengers sitting still in the train car. But if the train is moving 13 meters per second, that same person is actually moving 14 meters per second relative to the ground outside the train car. Motion is relative, which is why it must always be described relative to a frame of reference. Okay, so it always depends on the frame of reference, where the observer is compared to what is moving, or maybe it doesn't appear to be moving. Okay, so here's an example. Which do you think you could kick farther, a soccer ball or a bowling ball? If you were to kick both with the same force, the heavier bowling ball would accelerate less than the light soccer ball. As a result, the soccer ball would travel farther than the bowling ball. We can use force diagrams to represent Newton's laws. When using arrows to represent forces, several rules need to be followed to find the net force. The longer the arrow is, the stronger the force is. Draw the arrow in the direction of the force. Write the size of the force in newtons for each force arrow. If values are given, arrows going in the opposite direction must be subtracted from each other to find the net force. Arrows going in the same direction must be added to each other to find the net force. Here's an example. One person kicks the soccer ball at a force of 75 newtons. The arrow is longer because it is more force being applied than the other person who's kicking the soccer ball at only 50 newtons. Okay, so the net force is 25 newtons to the right. Unbalanced forces result in acceleration. The soccer ball will travel to the right because there's more, the net force is traveling in that direction. Okay. Another example, if they're both applying a force of 50 newtons, then the balances are, or the forces are balanced. So 50 newtons minus 50 newtons would result in a net force of 0. So we have balanced forces result in no acceleration. The soccer ball will not move. Okay, speed versus velocity. So these are similar terms, but they have different meanings. Speed refers to how fast something is moving. Velocity refers to both its speed and direction. For example, your speed might be 50 kilometers per hour, but your velocity is 50 kilometers per hour north. Speed and velocity can both be calculated by dividing the distance traveled by the time it took to travel that distance. If a toy car rolls 4 meters in 2 seconds, its speed is 2 meters per second, 4 divided by 2. If the car rolls to the right, then its velocity is 2 meters per second to the right. Here's an example problem. Look at the map. The red line shows the path that the person walked from home to school. Also look at the compass here that shows the directions north, south, east, and west. The path contains different sections. The boxes in the map describe how long the person took to walk each section. Describe the route in terms of distance and direction. Calculate the speed for each of the 5 segments of the trip. Give the velocities for each of the 5 segments. Calculate the average speed for the whole trip by adding all the individual distances and dividing the sum by the total time taken to complete the trip. Okay, so pause the video and find the speed for each segment, and then find the average speed, total distance divided by total time. Pause the video. Okay, now let's check your work. So for segment A, it has a speed of 90 meters, or it traveled 90 meters in 30 seconds. So it has a speed of 3 meters per second. Its velocity is 3 meters per second east. Must have a direction if it's velocity. Okay, you can go ahead and check your work. Pause the video and check your work. Make sure your answers are the same. If they're not, go back and revise. For average speed, we should add up all segments traveled. So total distance traveled is 640 meters. It took 200 seconds. So average speed is 3.2 meters per second. Quick summary. Newton's second law tells us there is a relationship between force, mass, and acceleration. Thanks for watching. Good luck.